Hey geometry folks. So in our previous class we were covering some parallel line reviews, mainly just the relationships that are formed when we have two parallel lines and it's being cut by a transversal. We have some very special relationships that happen with some of the angles that are present, right? So what I think might be helpful is to do a little bit more parallel line review, just because it does do a really good job of setting us up for proofs later on, especially with more complex figures like parallelograms. So let's just get started with this, right? So we covered a few things with parallel lines in our last lesson, right? So when parallel lines are cut by a transversal, alternate interior angles are equal, right? So we learned that fact, and corresponding angles as well are equal. And then when they have equal measurements, right, we call them congruent, right? So alternate interior angle measures are congruent, corresponding angle measures are congruent. The sum of the measures of all three angles of a triangle is always 180, right? And when I talk about the three angles in that triangle, I'm really talking about the three interior angles, right? And this is called the triangle sum theorem. And then finally, an exterior angle of a triangle is the sum of its remote interior angles, and as a result, an exterior angle must also be greater in measure than either of its two remote interior angles, right? And so once again, we learned this is the exterior angle theorem, and this falls under one of those triangle corollaries, triangle sum corollaries, right? And remember that the exterior angle is whatever angle is outside of one of your interior angles, and the two remaining angles are your remote interior angles. So let's go through a couple exercises to kind of expand on that knowledge that we've built upon in our previous lesson. So our first exercise here says a triangle is shown below with its sides extended. All angles have measures as shown. Calculate the value of the exterior angle at each vertex and justify that it is the sum of the two remote interior angles. So it looks like we have a few different angles going on here, right? So we first have angle 1, we have angle 2, and we have angle 3. Okay, so let's just look at angle 1 and just identify what its remote interior angles are. So angle 1 is the exterior angle to this angle that's measured 34 degrees. So the remaining two angles are 63 degrees and 83 degrees. Therefore, 63 and 83 must be the remote interior angles. For angle 2, right, it is the exterior angle to this angle measured 83 degrees. So whatever the remaining angles are, which are 63 and 34, those are going to be the remote interior angles. So let me just label that as well. So this is 63, 34. And then finally, we have angle 3 over here, and it is the exterior angle to this interior angle of 63 degrees. So the remaining two angles, 83 and 34, are going to be the remote interior angles to angle 3. So let's just write out those equations to exemplify that exterior angle theorem, right? So for angle 1, right, this is equal to 83 degrees and 63 degrees. Well, let's actually write that like it's not an exponent. Okay. Angle 2, based on my diagramming, is going to equal the sum of 63 degrees and 34 degrees. And then finally, angle 3, based on my exterior angle theorem, is going to be 83 degrees plus 34 degrees as labeled previously when I was first looking at the problem, right? So I'm just going to sum these values up. So when I have 83 plus 63, that's going to give me 146. When I have 63 plus 34, that's going to give me 97. Oh, let's make sure that we're staying consistent with our colors. That's going to give us 97 degrees. And then finally, 83 plus 34 is going to give me 117 degrees, right? And so, in order to verify this, right? So I'm saying that angle 1 is 146 degrees, angle 2 is 97 degrees, and angle 3 is 117 degrees, right? In order to verify this, I want to just get down to the definition of what an exterior angle is, right? And what an exterior angle is it is a supplementary angle to that interior angle that it is adjacent to. So when we're looking at angle 1, right, it is adjacent to angle this angle that's measured 34 degrees, right? So it should be supplementary to this. So in order to verify that angle 1 should actually be 146 degrees, I would just do 180 minus 34, right, to find out what that supplementary angle would be. And let's make sure that we're staying consistent with the colors. So 180 minus 34, and you betcha it's going to be 146. Same kind of thing for the other angles, right? So over here, it would be 180 minus this given angle of 83 degrees. And so, once again, you betcha it's going to be 97 degrees. And then finally over here, we have this given angle of 63 degrees, right? So if we do 180 minus 63, once again, you betcha it's going to be 117. Let's move on to the next exercise. Now that we know what properties arise when we know two lines are parallel, right? We also want to know how to prove two lines are parallel, right? So not just what we know when two lines are parallel, but we also want to prove that they are parallel. And so this can be done with a couple theories, right? These aren't the only theorems that will prove this, but then these are some of the theorems that will prove this. So the first theorem that will prove this is that lines will be parallel if any pair of corresponding angles are equal. So only if they're parallel will you have corresponding angles being congruent to each other. For a second one, right, if your lines are parallel, then any pair of alternate interior angles are going to be congruent as well, right? They're going to be equal in measure. So let's test this out. We will prove the first theorem using an indirect method of proof, and we will assume that two lines that have equal corresponding angles are not parallel and see what happens. In the following diagram, non-parallel lines M and N have been cut by transversal R to form two congruent angles 1 and 2. So we have angle 1 here and angle 2 here. So why does this scenario contradict what we know from above about the exterior angles of a triangle? Well, let's look at this piece of information that was given to us, right? So we know that angle 1 and angle 2 over here, they're going to be congruent to each other. So I'm actually going to draw my arc marks in order to show that. And I'm actually going to draw a tick mark through those because I think that those make it a little bit clearer that we have those two angles as being congruent, right? So if they are congruent, if I'm looking at line M and line N, they're being cut by this transversal R, right? And so when I look at 1 and 2, I see that angle 1 is on the top right angle position of this intersection here, and angle 2 is also the top right angle of this intersection over here as well. And so they're both in the same position, right? So angle 1 and angle 2 are congruent, right? But they're also corresponding angles. So if these corresponding angles are congruent, then we know that M is going to be parallel to N based on this first theorem that we had over here that proved whether or not two lines were going to be parallel. Okay, so when I look at angle 2, right, I notice that it's an exterior angle, and angle 1 is one of the interior angles, right? So if angle 2 is the exterior angle, right, then we know based on our exterior angle of a triangle theorem, right, that angle 2 is going to be equal to its two remote interior angles, and its two remote interior angles are going to be angle 1 and angle 3. However, that can't be true, right? Because this would be saying that angle 2, because it's the sum of angle 1 and some other angle measure, angle 2 is bigger than angle 1. But we know that's not the case, right? Because we know that angle 1 and angle 2 actually have the same angle measurement, right? So because angle 2 is not larger than angle 1, angle 2 cannot be equal to angle 1, right? That piece of information can't be true since we clearly have a triangle over here that would make the exterior angle theorem true, right? So what does this tell you when two corresponding angles are equal? When two corresponding angles are equal, then we know that the lines that they are on do not intersect, right? So they must be parallel. So the lines they are on must be parallel. We also knew one more thing, right? And we proved this when we were given a triangle, right? So you can never have corresponding angles that are congruent when you have a triangle formed, right? Because that, if you have a triangle formed, these lines are going to intersect at one point, which fundamentally goes against the definition of a parallel line. Let's look at exercise 3 in order to expand our knowledge on these theorems that we've been learning about, right? So it says in exercise 3, in the diagram below, lines P and S are cut by transversals. The angles are marked as shown. Explain why P and S must be parallel to each other. Okay, see a lot of lines. I'm actually just going to, so what I want to do is just actually look at the information that's given to me. And I see that a lot of lines are going on, so I know that I can be pretty easily overwhelmed, but let's not focus on that, right? Let's look at all this wonderful information that was given. So I see over here, I have the 63 degrees, okay? And 63 degrees, I see that there are a lot of lines that are getting intersected, right? Like I have a line here being intersected with this line and this line. Okay, other than worrying about all those intersections, I'm actually going to use that to my advantage because I know that when two lines are intersecting, one of my angle relationships I can always rely on is a vertical angle. And I see that there's a vertical angle to this angle that's given over here, right? And that vertical angle is going to be right over here. So I know that this is also going to be 63 degrees. Now, I know that this angle right over here, right? Let me highlight this as blue. Okay. I know that this angle plus this angle that's measured 63 degrees and this other given angle, 74 degrees, they all form a straight line, right? So because they're forming this wonderful straight line over here, I know that they're all going to add up to 180 degrees. And so let me just actually write an equation that can help me out with that. So I know that this angle, and I'm going to call it, let me call it T, right? So I know that T plus 63 degrees plus 74 degrees is going to equal 180. Now, when I solve for this, right, I can combine these like terms. So I have T plus 137 equals 180 degrees. Subtract 137 on both sides, so I get T equals 43 degrees. Okay, so I know that T is actually 43 degrees. When I look at this angle T, right, I notice that it's in the top left, right? The top left quadrant of this. So this is actually where it might be helpful to actually just go in and actually erase some parts that might be a little bit confusing to you. So I'm just going to erase this line over here just to help me see things a little bit clearer. I'm going to erase this angle. I'm going to erase this, right? This is all just to see the image a little bit more clearly. So I can just focus on this one transversal, right? So when I look at this, I see that this angle that's measured 43 degrees is actually in the same position as this given angle that's measured 43 degrees. And so because these are both in the same position, they're corresponding angles, and I see that they're congruent because they're the same measure, right? So because corresponding angles, I should probably write in a color other than white, corresponding angles are congruent. Therefore, we know that P is going to be parallel to S because of that theorem that we covered previously. Let's move on. Exercise number 4. In the following diagram, A is parallel to B, so let me just annotate that. So A is parallel to B, and B is parallel to C. So B is parallel to C. And I want to prove that A is parallel to C. So this is actually going to be really important because it's going to lead us to something called our transitive property later on when we do proofs. But let's actually just prove this for ourselves, right? So if A and B are parallel, right? So if A is parallel to B, then I know some things about some of the angles that we have present, right? So I see angle 1 and angle 2. Angle 1 and angle 2 are going to be congruent to each other. And the reason why I know this is because their angle relationship is alternate interior angles. And I know that alternate interior angles, if you have parallel lines, are going to be congruent. So because alternate interior angles in parallel lines are congruent. Now I'm going to do shorthand. Okay. All right. And cool thing that I know is that 2 and 3 are vertical angles, right? So 2 and 3, angle 2 and 3 are congruent because vertical angles, they're always just going to be congruent. And we can prove that actually with our supplementary line theorem. So vertical angles are congruent. Okay. And if I look at lines B and C, right? So I know that B is parallel to C, right? And I see that angle 3 and angle 4 are actually going to be congruent as well, right? So angle 3 and angle 4 are congruent for the same reason why angle 1 and angle 2 are congruent, right? This is another set of alternate interior angles, right? So same reason, because alt interior angles in parallel lines are congruent, right? Therefore, right, because I had that angle 1 was equal to angle 2, angle 2 was equal to angle 3, and angle 3 was equal to angle 4, by this long line of transitivity, I see that angle 1 and angle 4 fall in the same equivalent statement, right? So angle 1 and angle 4 would therefore be alternate interior angles to lines A and C. So because of transitivity, that's what we call this property when we have a long line of equations that we just strung together because we saw that one part kind of latched onto the other. So because of transitivity, right, we have that angle 1 is equal to angle 4. And because of that, we can use our previous theorem, alternate interior angles are congruent if you have a parallel line. And I apologize greatly for my horrible handwriting. So because our alternate interior angles are congruent, right, we know that we do have parallel lines. So we can conclude, let me write this over here, can conclude A is parallel to C because we were able to prove that its alternate interior angles, right, angles 1 and angle 4 were congruent to each other. Right. Final exercise. So as we've seen, parallel lines and triangles are linked through various principles, including the most famous link of the 180-degree sum of its internal or interior angles. So we should be prepared to use parallel line properties in proofs involving triangles and vice versa. Right. So let's look at this triangle below. So in this triangle below, AC and DF bisect each other at E. Right. So I know that AC is bisected by E. So this segment is bisected by E. So I know that AE and EC are going to be congruent to each other. So let me just mark that, AE and EC. And then also that DF is bisected, right? So I know that DF is bisected, so DE and EF are congruent. So let me just mark that with 2. Okay, so we would like to prove that AD is parallel to FC. Okay, so we don't know that yet, right? So we can't say whether or not our alternate interior angles are congruent or whether our corresponding angles would be congruent. So we want to state all pairs of angles, if proved equal, that would let you conclude if AD is parallel to FC, right? And so that means that we want some corresponding angles, or we want some alternate interior angles, right? And lucky for us, we have a boatload of alternate interior angles that we can point to, right? So we can point to this interior angle, right? It would be an alternate interior angle to this angle, right? So let's say that if angle, let's name this angle EAD, if this were congruent to angle ECF, oh boy, we would just know for a fact that FC and AD were congruent, right? We also have another alternate interior angle going on here, right? So we have this angle, and it's alternate interior angles with that, right? And so we know that if we knew EDA was congruent to EFC, that would also help us out a lot, right? So how can we prove these angles are congruent, right? So let's just look at this a little bit. So we know that these two angles are going to be congruent, right? Because angle, let's name this AED, is going to be congruent to FEC, angle FEC. And we know that they're going to be congruent because they're vertical angles. So let me actually get rid of this because I don't know why I wrote that there. So goodbye. Because, okay, so we know they're congruent because they're vertical angles, and vertical angles are always congruent to each other, right? And I see that these two triangles are actually going to be congruent, right? And we're going to cover this a little bit more in depth. I don't believe that you covered this in your previous lesson, but we know that we can prove that two triangles are going to be congruent based on this criteria called side, angle, side. So we have a side of each triangle that's congruent. We have an angle right after that's congruent. And then the following side is also congruent. So because the side, angle, and side, angle, side are congruent, we know that these two triangles, so triangle DEA is going to be congruent to triangle FEC, right? And so, based on another theorem where corresponding parts of congruent triangles are going to be congruent, right? We know that these two triangles that we stated in part A are going to be congruent too because they're corresponding angles in those triangles, right? So we know that this is going to be congruent to each other. We know this is going to be congruent to each other. Make that 2 tick marks. 3. There we go. Okay. So, and we were able to prove this, sorry, a little bit all over the place, by SAS, side, angle, side. And then finally, we were able to say that these two angles that we needed, so angle EAD, I'm just going to pick one, was congruent to angle ECF by corresponding parts of congruent triangles are congruent. So CPCTC. That's how we abbreviate it. Right? And so we finished the proof just by saying, right, that AD is parallel to FC because their alternate interior angle measures are congruent, right? And we know that two lines are parallel. We can prove that they're parallel as long as their alternate interior angles, any given alternate interior angle is going to be congruent. And we know that the other pair of alternate interior angles that we had going on here, angle EDA and angle EFC, were also going to be congruent based on the same criteria, CPCTC. Okay? So, hope that was helpful, right? You have some practice problems on the next page that require you to use a lot of the same skills that we covered in our notes. So if you have any questions, make sure that you're pointing to the specific exercise or the specific problem inside your homework that will can be a little bit more specific, so I can help you pinpoint exactly what you might be struggling with. And remember that I can also be reached by Google Voice or through email as well. So good luck, and if you have any questions, shoot them out.